Okay, let's do a quick revision for electrostatics. This is for science physics, take note, not pure physics. Okay, so for electrostatics, okay, you must remember there are two types of charges, positive and negative charges. And when we say that something is neutral, what does neutral mean? It does not mean no charges. Okay, that's what some people think, okay, or call it neutrally charged. Okay, no. Neutral means the equal number of positive and negative charges. So by default, everything is neutral, okay, unless it has become charged. And if it's charged, it means it's either negatively charged or positively charged. So when it's negatively charged, it means it has more negative than positive charges. It does not mean that there is no positive at all. It's simply that there are more negative than positive charges. So likewise, positive charge more positive than negative charges, right? Then the formula we will associate in this chapter is Q equals IT. Remember, Q stands for charge, and the units is C, which is Coulomb. And of course, there's current and time. You must remember is in seconds, right? Okay, let's go down to the main things quickly. Okay, there's two methods of charging that you need to take note of. Okay, one is by friction. Okay, friction happens when you got two materials rub against each other. Friction between the surfaces separates the electric charge such that one becomes positive and the other one negative. Okay, so this is a good phrase to learn. Okay, so for example, most often you're asked if a cloth is rubbed against a plastic rod. Okay, then the rod becomes charged. It is being charged by friction. Okay, two objects, okay, two bodies, two materials. Okay, the friction between them causes them to be charged. And okay, the two materials most commonly you must know is polythene and acetate. Acetate, for this acetate, it will become negatively charged. Let's go back again. For polythene, it will become negatively charged. For acetate, it will become positively charged. And then the cloth will be of the opposite charge. Okay, you must remember that only electrons move. Okay, so the key idea here, always talk in terms of electron movement. Okay, your positive charge cannot move, it's your electrons that move. So for example, if you rub a cotton cloth with an acetate rod, okay, the acetate rod you know is going to be positively charged. So what happens? Okay, with your notes, it says friction separates the charge such that acetate, the electrons move from acetate to cotton. Why? Because you know the acetate is going to become positively charged. So the electrons go to the cotton cloth. So that leaves the acetate rod being positively charged while your cotton cloth becoming negatively charged. Okay, so we talk in terms of electron movement. Do not write in terms of, okay, the positive charge move to the acetate. Once you say that, then that's wrong. Okay, and then why do they move? Okay, the main reason in this chapter, okay, which you must remember, is unlike charges attract, like charges repel. Okay, this applies to a lot of situations, especially in electrostatic induction, which we talk about later. Okay, then we move on. Okay, here there's testing of charges. You can go and read yourself. How do you test a rod is positive or negatively charged? Go and read. You can be asked about this. So if this rod moves towards this rod B, which is negatively charged, that means the rod A has to be positively charged. Why? Because unlike charges attract. So we use the law of electrostatics. Okay, then down to definitions. Pay attention to electric field, okay, and electric lines of force. These are two definitions you must know, and as I always say, learn the exact phrasing. Okay, try not to use your own words, you tend to be wrong. Okay, and then after that, drawing of electric field. Okay, when you draw electric field, okay, draw it properly. Okay, this I think is one of the things that will surely come out, and draw it such that the arrows always point from the positive to the negative. Okay, they out from the positive in towards the negative, like this. Alright, so this is the way you should always draw. You can check a textbook and make sure you draw them nicely using a pencil and even a ruler. okay, and then when they attract, okay, they join up together, and again, don't neglect to draw this side. Again, what are the arrows? They are going inwards. Okay, make sure you know this well. And then for two negative charges, repelling, right? So you see the fields run in this manner, running parallel to each other. Okay, so make sure you know how to draw, not difficult, it will come out. Okay, then after that, okay, we come to electrostatic induction. Okay, what is electrostatic induction? These are situations where you have a rod or some object which is very charged brought close. It's always brought close. It's never touching. It's brought close to something else. Okay, so in like this case, question 1, this negative charge rod is brought close to this sphere. Then they'll ask you, okay, how is this sphere charged, and so on and so on. Okay, so you see this negative, if you were to draw, you'll probably just draw here positive. Okay, you're going to draw 5 positive, make sure here is 5 negative, then this side you draw negative, right? So when you explain, when I taught you, I told you, explain in terms of electron movement, give the reason and overall effect. So talk about electron movement. So for this sphere, in this case, you can make your life easy. You call this side A, side B. So you can start off by saying, okay, when the negatively charged rod is brought close to the sphere, okay, brought close to the sphere, this is a good intro statement. Not getting the answer yet. What happens next? Okay, what happens? We talk in terms of electron movement. Okay, you will say that the electrons on the sphere move to the left side, or you can just say side B, right? So talk about electron movement or the negative charge particles. Okay, the negative charges move to the left side. Okay, that's what you say. What is the reason? Give the reason for it. Remember, second one. Okay, this is E, right? That R, reason. Why? Because like charges repel. Okay, this negative charge rod repels the negative to the other side. And then what's your overall effect? Very often we forgot to say about overall effect. Overall effect is that, okay, you say the left side becomes what? Negatively charged. The right side or side A becomes positively charged. So that is your overall effect. So use this guideline to help yourself answer the question. Okay, what you should not do is to say positive charges move to side A. Once you say that, then that's wrong. Okay, because remember, I keep saying positive charges cannot move. Okay, so talk in terms of electron movement. So that's the way you could answer this kind of question, right? Okay, then there are other questions along. Okay, like for example this one. This is an O-level question. Okay, you were to read this question carefully. You take note. You say what? This is a metal rod. Okay, they even tell you they are okay. They give you the clue that only negative charges are free to move. That means your electrons, and that this rod and the foil, there are no charge. Okay, no overall charge, meaning they are neutral. Okay, and then what happens? They say brought close. So once again, they say brought close. Brought close, you think about electrostatic induction. So how do we do that? Again, give an intro statement. When the negatively charged rod is brought close to the metal rod, okay, full stop. What happens? Electrostatic induction takes place. How do electrons move? Electrons on the top of the metal rod move down towards the metal rod and the foil, right? So negative charges here, they move down. Why? Because they are being repelled as like charges repel. Okay, and then as a result, okay, don't stop there. Once you take next, talk about overall effect. Overall effect, the top becomes positively charged. The bottom of the rod and the metal foil are both negatively charged, and since they are both negatively charged, they repel from each other. This foil move away from this bottom of the rod as like charges repel. Okay, so I didn't write it down, so you just rewind, pause, and you can write it down. So basically, electron movement, the negative charges move down to the metal foil and the rod. Reason, like charges repel. Overall effect, bottom, everything here negatively charged, here negatively charged, they repel and move apart. So that's the way you answer, right? So again, another example. So likewise for this one, when you bring the rod close to the paper, what happens? Electrons move to the top of the paper. Electrons move to the top of the paper. Reason, unlike charges attract. Okay. Secondly, after that, overall effect, the top is negatively charged, the bottom is positively charged, and if this piece of paper is small enough, this piece of paper will fly towards the rod. Okay, they get attracted towards the rod. Why? Because unlike charges attract. Okay, so this guideline is very useful in talking in terms, explaining, okay, making sure you get all your answers in. Alright, so expect this kind of questions. Alright, this one is O-level question. This is also similar, and then also likewise another O-level question. Right, so this one, what happens? Negative charge cloud above. Then they give you all the clues. Again, they say negative charge particles are free to move within the copper. Okay, and then after that, describe what happens when the cloud comes above. Okay, when the cloud comes above, what happens? Electron movement. Okay, electron movement. What happens? The negative charges, the negative charge particles from the top go down to the ground. Right? Reason? Like charges repel. Negative repel, they go down. Overall effect, the top becomes positively charged as a result, right? Okay, you can stop there. In actual fact, in reality, why you have a lightning rod? So here is strongly positive charge. So that the negative charge, anything that's charged, like this, anything is charged want to become neutral. So the excess electrons will go down, strike the lightning conductor and go down towards the earth because it's very strongly positive charged. So once the excess negative charges leave the thundercloud, okay, the cloud becomes neutral because anything that's charged will want to become neutral. Okay, so again, another O-level question, another case when you see, okay, brought close, you answer like that. Okay, electrostatic induction. Okay, so anyways, charging by friction, you got two materials rubbing against each other, okay, producing friction. Then this is friction. So be able to differentiate the two. And then when you are explaining, okay, be sure to explain in terms of, as I keep saying, electron movement. Don't use wrong terms also. Don't say things like negatively charged or positively charged electrons. There's no such thing in there, okay? So, or neutral charge, okay, there's no such thing as that as well, right? Or neutrally charged, you just say it's neutral, right? Then the rest, you go and practice on your own, right? As you practice, you will see, this one, okay, rub with fur, then you know it's friction already, okay? Then what happens, okay? You can see, you can very quickly discount A and C. Why? Because they talk in terms of photons moving, is electron moving, okay? So the rest of it, go and have a practice yourself. Look at how you answer the questions. All right.